plain old gravity. Hey, let's help you out with this. To avoid injury, don't lift, pull, or push too much. Let your posture guide you. And if need be, get help or use a hand truck or other tool. Also, move that body. If you stand up a lot for work, sit. If you've been sitting, stand up. Every change is an opportunity to realign and think about your posture. Our last Ergo 101 topic is repetitive motion. Doing the same task over and over and over and over and over and over. Well, you get the point. Repetitive motions from jobs like these can cause carpal tunnel syndrome, joint problems, poor circulation, and more. Fortunately, these injuries are easy to avoid. First, by arranging your work area to fit you and support good posture, and second, by stretching. Stretches like this, or this, or this, well, maybe not that. Every 30 to 60 minutes can make a world of difference and prevent injury. Show off. Let's recap. Ergonomics is all about fitting your work environment to you. So set up your station to support good posture. Be mindful of posture, reduce forces, and take breaks to stretch and realign yourself. Do all that, and you'll be on your way to being more efficient, more productive, and healthier.
Thank you for watching. Hope the message is clear about ergonomics. It is very essential for the people who is working and sitting in the offices. So take care of ergonomics. So now I'd like to welcome our President, Mr. Badral Hadrami, for presidential address. Mr. President. Okay, seems to be he got disconnected. So
yeah, he was there, he got disconnected. Once he come back, we'll
no problem. He wanted to convey his regards to all the members who had joined. There are many activities are being carried out through ASSP Kuwait chapter, and many more activities are going to come. You can see the glimpses of activities, what has been done so far, and what are the activities are coming up. So stay tuned. This is once the president will join, he'll speak. So let's move forward. Next slide, please. So briefing of chapter activities. So we are proud to announce ASSP Kuwait chapter has awarded with the Platinum Chapter Award for 8th time in past 9 years. So Alhamdulillah, this is for the term 2023-24. Hope to expect another Platinum Award for 24-25 as well.
You grow in your career?
All right. First of all, it's certainly a pleasure, Vikram, to be here with you to have this conversation. And to answer your question, to be honest, you have to surround yourself with successful people in the field you are planning to work with. So this is one of the things that I consider as one of the critical factors that supported me in my career, which was joining ASSP and surrounding myself with successful professionals in the field who helped me grow my career, guided me towards the right direction. So to put it into this perspective, I would say surround yourself with people who could support you and guide you to the right direction in your career.
That's great.
So we wanted to inform you that ASSP Kuwait chapter has had its first episode of podcast. We thought of introducing this podcast thing to all ASSPNs. So we started this one with our president. So we are going to reach out to our leaders, advisory committee members, and the mentors of ASSP, one after the other, to listen from them what their success stories, what they have contributed towards ASSP Kuwait chapter, and other things. This is you can say a first episode for podcast. So just for your information. Next. So recently we thought of, and as you all know, that ASSP has got certification, sorry, what you called authorized to conduct training. So we got approved from KPC So in order to have much more trainings through ASSP Kuwait chapter, like certification programs, certificate programs, and all of that, so we thought of call for trainers, asking for trainers to, we have circulated a Google form to ask the nominations to be trainers, in-house trainers, we can say, to ASSP Kuwait chapter to deliver trainings like professional trainings, technical meets, commercial trainings, training certification programs, these all kind of things. So we are expecting much more nominations on this regard based on the nominations we have received and what the expertise they have in particular field. Based on that, we're going to have different technical meets and training programs. Many other things are going to do in the days to come. So if at all you people are having anything, uh, means you people are willing to nominate yourself as a trainer with ASSP as wanted to collaborate. So please fill and submit. The Google form has been shared through different social medias of ASSP Kuwait chapter. So this is all about this call for trainers. And as you all know, we're doing many activities in terms of chapter events, we can say. So technical meets, GCC awards, PDC, many more. So to have a collaboration with its business partners and anyone who's willing to share or collaborate with ASSP Kuwait chapter. So we had circulated this thing as well for call for your brand at the forefront of safety innovation, you can say, sponsorship opportunities to business partners and other what do you call NGOs, organizations, whatever you can say, where you can have an opportunity to collaborate and have trainings and technical meets, events, kind of. So next slide, please. So about the training programs which have conducted. So this is BOHS Module 507, Health Effects of Hazardous Substances. We had it on 28th to 28th September 2024. Around 10 participants has got benefited through this training program. This industrial hygiene module. And then we had our first technical PSM technical meet, you can say 31st and first of this tenure 2024-25. And today's technical meet is second PSM technical meet, you can say. So Mr. Devendra Rathod was the speaker on this. So around 50, 60 plus participants got benefited from this technical meet held on 30th September 2024. So from Vice Committee, we had a Vice event on 10th October at Australian University Kuwait on the title called Steps of Safety and Health in the University Environment. So many delegates, and it is in collaboration with the Kuwait Fire Department, Kuwait Fire Force. So you can see the glimpses, many delegates and different organizations has joined hands in this training program. So another event from Vice held on 28 November 2024 at Kuwait Society of Engineers. Our event Unite to be Stronger Together. It is an awareness on breast cancer. This is from Vice Committee. And day before yesterday, I guess, we have 4th to 9th of November, we had ISO 9001 2015 lead auditor course. Around 12 participants had got benefited through this certification program. Next, please. So as I told you, like we are called for the trainer. So we had an opportunity to deliver a training for PCIC through ASSP Kuwait chapter on 11th and 12th on first hand at CPR. So these are the glimpse. So we had successfully organized a training program for in-house training for them. We went there to their premises and delivered this training, providing certificate through ASSP. And these are glimpse for that. So these are the upcoming events, we can say, newsletter. Today only November e-newsletter also has been released. I hope you have received it through a social media WhatsApp broadcast. So these are the upcoming training programs. I can say training on overview of crane safety and rigging safety. On 22nd November it is. And another program, professional writing workshop for publication and book writing. This is going to held on 27th November, and the certificate PHA Hazab lead course training program. It is 8 to 11th December. And even we're planning to have a contractors day in December, hopefully, in collaboration with any of our business partners or a service provider, like in KOC, Hubara Center or Uni Center, like that. We're planning in December, in the month of December, before our GCC HS Excellence Award. So usually we have a regular practice of appreciating and congratulating our members who had achieved different certifications in terms in the field of HSE. So join hands with me to congratulate Mr. Narendra Patil, our core member of ASSP, on achieving CSP credentials from Board of Certified Safety Professionals, BCSP. Next, please. So we are glad and happy to thank and honoring Mr. Dinesh Datta, our past core committee member, we can say, had served ASSP Kuwait chapter as a treasurer for the term 2014 and 15, and was a vice president for 2015 and 16. As he retired from KNPC, he had traveled to India for his better future. So we wanted to thank and our gratitude for Mr. Dinesh Datta for his services towards ASSP Kuwait chapter. Actually, we requested to join him because of some circumstances. He couldn't able to join to say a few words, share a few words with us. The next, please. So as you all know, ASSP Kuwait chapter is having its own Toastmasters club called Kuwait ASSP Kuwait Toastmasters Club. So the Toastmasters meetings of ASSP are going happening every second and fourth Saturday of every month. So whoever are interested to be members of Toastmasters, you can join. You can contact any of the core members of Toastmasters or ASSP, so that we can guide you to be a members to enhance your speaking abilities and communication skills as a HSE professional, I can say. So upcoming events of ASSP Kuwait chapter. Next slide, please. So GCC HSE Excellence Award, as you all know, it has been circulating since long. So 30th was the last date for application submission. So it has already finished. So award declaration on November 30th we are going to have, and award ceremony is on December 19th at the KOC tent Ahmadi. So this is the glimpse. This is the brochure. So the many companies has been nominated and participated this time. Hope to have them all see in the event day. And this is another mega event of ASSP Kuwait chapter, GCC HSE Excellence Award. It has kick-started its activities. We have got selected our venue, Crown Plaza for Mania. So for the speaker invitation, we have already circulated for the PDC invitation for speakers. Whereas in the future, many things invitation for exhibitors and other things, we are going to circulate it one after the other. So it has been circulated already. So whoever are interested to be a speaker in PDC, so they can nominate or submit the papers. So the PDC is going to held May 7th and 8th of 2025. So these are upcoming events, as I already explained about the training overview of crane safety, going to take by Mr. Muruganantham, and professional writing workshop from publication to book writing, and certified PHA Hazab leader course. It is another one. So these are the three programs are in pipeline. I request all who are interested to nominate yourselves and make use of the opportunity. So now I'd like to call Mr. Najas T. Abdul Karim, Head of Energy and Sustainability Committee, to introduce our today's speakers. Thank you very much. Welcome once again. Enjoy the trainings. Over to you,
Good
Mr.
evening,
Najas.
sir.
Thank you. Yes, Najas.
Assalamu alaikum. Good evening.
Walaikum salam.
Yeah, today's first speaker is Mr. Venkatacharya Narasimham. we can able to say age doesn't matters. Okay, so he is running 75 plus, and still are very much active in the field of process safety. And we can take one of the pioneers in process safety management. Today, we got an opportunity from Mr. Narasimhan to provide some of the basics of process safety management. All we are about maybe we are in different field, but we don't know what are the basics of process safety. So let us start from the basics. Okay, Mr. Narasimhan is having wide 36 years of experience in process safety. Did worked in fertilizers, oil and gas, and worked as a consultant for different entities and conducted a lot of webinars and safety audits. So we got the right person to talk about the process safety. Let me welcome Mr. Venkatadhar Narasimhan for the speak. Welcome, sir. Can you unmute, please, sir? Ramana,
Stop sharing the
Mr.
screen. Let the first speaker share the screen and deliver the training, please.
It's
you.
it's unmute. Unmute, please, Ramana, Mr. Ramana.
Done.
Yeah, it's still not.
ఇప్పుడు ఎలాగో లేస్తున్నాను
No, not
అవసరం లేదు.
Request all the participants in the meeting to mute themselves and switch off your camera to not interrupt the session, please. Thank you.
Narasimhan sir, could you please
Unmute.
yeah, now it's
Yeah,
okay.
yeah. Thank you, sir. Welcome. Once again, welcome.
Okay, thank you.
Now it's audible, sir.
Okay. Shall we talk now?
Yeah, sure. It's audible. Please, sir.
Go ahead, sir.
Okay.
We're excited to hear from you.
Okay. Thank you. It is already time. Only 40 minutes or 1 hour?
40 minutes, sir. You can
40 minutes, sir.
We'll see then
Okay,
later.
Okay. We have the late has been belated.
Yes,
No,
sir.
what I'm going to talk about process safety management system that is first introduced in our company in 1995. I underwent training for about 10 years, and then I was a chief manager for ammonia terminal. I have worked in different plants, different capacities. I got retired in 2008. From then onwards, I was working with the greatest Pitamaha of safety, Mr. Ramadurai. I was with him for about 10 years. And then I started my company, NS Associates. Then for 5 years, I was with my friend. Then I started my own from 2021, and I'm continuing. I have done a lot of things. I have got membership throughout the world. World Economic Forum, World Bank, one of the consultants, and then World Academy of Sciences and Technology, and then American Institute of Chemical Engineers, Institute of Chemical Engineers, UK, and so on and so forth. There are a lot of membership and a lot of accolades from so many things I have done. So what we are going to talk about, how the OSHA has worked. In 1883, DuPont, the first company, French company, started carbon black in France. Say they wanted to have a perfect process safety management system. Then during the 19th century. But all the people who are working with the managers who are all, they are not well educated. So that was given up. So in 1912, the first industrial revolution took place. Lot of faulty measures and lot of gases emanating from the chimneys. People not aware. People were dying. They don't know what to do. Because it's the first thing they have seen. Fault machines were erected and a lot of chemical industries sprung up. They don't know what to do. So people were dying. The owners, they were not caring about. Then the World War between 1914 to 1919 by German Kaiser, he started invading Europe. So everything went unheeded. Then the second industrial revolution take place in 1925. The same old story repeated. People were dying. They don't know what to do. The faulty machine were installed. Again, the same old story. A lot of poisonous gases coming from chimneys. Then the Second World War came, 1939 to 1945. Now people were all educated. They don't know what to do, what of things. Then the story came in 1984, Bhopal incident, and 2,000 people died. And then Phillips Petroleum Company, disaster, 23 people died. And then 3 Mile Island, disaster. Lot of things. Then only they have started thinking about a comprehensive policy they wanted to have. So after 1984, between 1990 and 1992, there was a meeting in Houston. A lot of inquiries were made. 1492 pages were written. At last, in Washington, D.C., a comprehensive policy was made. Air Act amendment was made in 1990. Along with that, then the US administration of labor made a comprehensive policy of process safety management system for process industry or any industry for the matter in 1992, Washington, D.C. First, they were introduced 14 elements. Now later on to 17 elements. I wanted to tell you how did happen in Bhopal. Then, because 1 or 2 episodes you must know, how would it happen? Then you cannot just know how the history was born. The Union Carbide of India, they have erected 2 plants at Jammu and Bhopal. They wanted to produce 7. They were taking MIC liquid from the Jammu plant to the Bhopal plant by rail tanker. They thought of it. Why should we spend so much money on that? So they wanted to start in 1979 itself. So they made arrangements to produce 7 on the Bhopal plant itself. First of all, a lot of people were pouring the MIC liquid to the tank by buckets. A lot of people, 27 people got injured. The union spoke to the management about the irregular fire. Union management did not heed to their words. Then one chemical engineer got burnt when he was working with MIC liquid. He got 30% burnt, died away. So most irregular safety management was not at all there. Union Carbide has not cared for the safety of the people or the plant. So what has happened? The greatest tragedy of mankind has taken place on the December 2nd of 1984. There were 3 tanks, underground tanks. They were keeping MIC. They cannot fully the tank. It's not possible. So they were filling it up to the off of it, all 45 tons, 45 tons, 45 tons. They have above the liquid, they had to give nitrogen blanket. So they have produced. Then what has happened? Freon 22 gas was not available. Coolant was not available. Refrigeration system was not working. Then flat system, they have removed for repairs. In spite of that, they wanted to manufacture 7. 2 tanks have been taken for production. The only tank that was V605, 611, 609. So they have emptied out 611 and 609. They could not empty out the 605 tank because nitrogen blanket has not been given for the past 1.5 years. So they were struggling. What has happened? At 12:30 on the morning of December 2nd, one supervisor, I don't want to tell the name, I know that, and another operator was standing, was in the panel. The pressure gauge was showing 10 psi at 10:30. So the two instrument people came and checked the veracity of the instrument pressure gauge. It says it okay. At 12:30 they got a noise, loud noise from the top of the tank. So the supervisor asked the worker to go and see what has happened. There was the top of the tank slab was broken. Why we don't know. Then at 12:30 they have taken tea. At 2:30, what has happened? Somehow the mystery is not known. Nobody knows. Around 2:30, from the evening of December 2nd, 1st of December, the moisture entered the tank at the bottom, and wild reaction with MIC on 22nd morning at 2:30 started going up because of the exothermic reaction, because it is +2 degrees. Water is 30 degrees. So what will happen? So +2 and 30 degrees started boiling. So slowly the MIC started lifting up because there was no nitrogen blanket has been given. It went through PRC. PRC is not serviced for quite long time. Started blowing from 2:30 to 4:30. People not aware because it has got a cloud intensity. It will go through the bottom and then will go up. People, 30,000 people got injured. 2,000 people died. The siren was deactivated in 1982 itself. The incident was reported to the nearest police station in Bhopal at 4:30 a.m. By that time, everything was over. So it's the greatest man tragedy. People were still, could not, because I was working in a plant where in ammonia plant, I've been working for 14 years. Then I worked in different plants, sulfuric acid, phosphoric acid, and utilities and ammonia terminal. I worked in different plants, different fertilizer stream, everything. I know the intricacies of the plant very well. This is the greatest man tragedy done by the Union Carbide. The mystery is not known. Still, they were not able to find out. $450 million has been given as compensation for the people. The only middleman enjoyed it. The director of Union Carbide was allowed to fly to USA, Mr. William Anderson Jr. Still, the case is going on in the International Court of Law. This is the story of Bhopal, but nobody knows what has happened. Now they have Dow Chemical has taken over the plant, but it's still under what they are going to do, I don't know. Then we will go to introduction about process safety. You must know what is, before going to the subject, you must know what is safety, what is risk, what is hazard, and then environment. Safety means is a relative freedom free from disease, fire, or floods, or by any other means of accident. Because I can't tell you, because I have been given only short duration. 40 minutes. So I have to compulsorily I have to talk about what is it. So safety is a relative freedom, free from disease, fire, or flood, or by any other means of accident. Suppose for example, suppose you are going on a footpath. Suppose you are tripping. Suppose you are trip and fall. Suppose you have to see on both your eyes on the footpath only. You cannot divert your attention to that side or that side. Your focus is only on the path. That's called personal safety. Same way, suppose you are going and crossing the intersection of the road. Suppose the amber light blinks. You have to be careful. When you want to cross the yellow line, when the green light comes only, you can cross. Suppose you cross the yellow line, when the amber blinks, what will you do? The crisscrossing of vehicles, it will hurt you. You get caught in the melee. Your life is lost forever. So that is also personal safety. So I don't want to go further. I can tell about fire, floods, and so many things because I don't have time. I have to rush through. Then we call risk. Risk is specific effect with specific due to complex of probability and consequence of vulnerability. Suppose you are going on a highway. Suppose a man crisscrosses. I'm not talking about any Gulf or American. I have seen in the American roads are perfect. Because I have been visited twice to America because my daughter is staying there. I have stayed for an year. I have seen that the road discipline is fakka. Whereas in India, we are constructing huge investment. We are doing it, but still the roadful carefulness not there. When you cross, suppose a man crisscross, suppose you are driving, when a man crisscrosses the way, what will you do? You have to turn the wheel to the right or left, or in the middle you will get caught and you get injury on yourself. Other man will be hit. So the complex of probability you may not aware that you are going to crisscross the man or you get injury. Complex of probability and consequence of vulnerability. Consequence of vulnerability you don't know. So this is the risk. Risk and safety are brothers and sisters. So you have to be very careful. You cannot, without risk, you cannot do anything. Safety is enforced, you can avoid risk, that's all. You cannot enforce strict 100% safety discipline. You have to take risk. Suppose you want to take up a job. Is it riskful? But you have to take. There is no other alternative. You have to take. So safety and risk are brothers and sisters. Then hazard. Hazard means which can be of anything or change, whether it is a biological hazard or a chemical hazard or physical hazard. So I am giving you more example. PEP example. In India, Haryana and Punjab, the farmers are burning the stubble. That smog is coming to Delhi. People are suffering because of that asthma they are getting. So it is very, very pathetic on the part of Punjab farmers, and the government has told so many things, but they are not heeding to the things. Now I think it is better than what it was. I have seen in one day during the Pongal holidays, January 13, smog was coming from the northern side of the city. That has come from Delhi. The people's stubble smog is coming. So that is the kind of situation. So that we have to avoid. So when I was training in 1970, when after my passing out my chemical engineering, I went and visited Manali area in Chennai. That was really non-polluted area. Now it is polluted. I went for some safety audit in 2013 under the guidance of Ram safety consultant chief consultant, Mr. Ramadurai. Then there was completely polluted area. Now it is completely polluted. So that is the situation we have to avoid. The people started constructing house nearby area, nearby the factories, because they are getting accumulation of diseases. I am not what I can say. I don't want to say anything more than that. Environments means clear. Environment. It should be, because in another 20, 30, 40 years, Madras is, Chennai is around 10 meters below the sea. So we have done, Ram Safety Consultant, when I was with them, we have done a coastal study for the entire sea coast of eastern side. We have submitted the project from Thoothukudi to Calcutta. In another 30, 40 years, the sea will swallow the entire region. They don't know. We submitted the project that is sleeping in the dusk of Government of India. Next, we will go. Objective. What is objective? Creating awareness among employees and professionals. Developing positive behavior. Next, please. Next page. To control process industry related risk. To identify process hazard. To prevent potential of adverse effect. Increase organization, reputation, and success of business. Fulfill legal requirements. What is the objective? Suppose you want to start a factory of your own. You must know the intricacies of the plant. Then only you can venture into the business. You must know the you must develop creativity. Then you can do your business. Likewise, if you want to create awareness among employees about safety and its other things and professional ethics, you can do very well. The management can be very happy. Developing positive behavior among people to control process industry. If you have behavior based, I have given a lecture on behavior safety for J&A Global Safety Consultancy, IIT Kharagpur, IIT Bombay. I have told them, if you have positive character, positive mind, positive thinking, you can do wonders. If you have negative character, negative thinking, that will lead to disaster. What has happened? That has happened in Bhopal. So you must have, suppose any worker who comes from home, he must have positive thinking, positive character, and positive mind. He can work very well. If you have negative mind, that will lead to disaster among people. That also lead the industry to go to docks to identify process hazard. So suppose you are working in an ammonia plant. So you must know the intricacies of ammonia. What is ammonia? What is other thing? So I worked in ammonia for about quite long time, about 25 years. I know the intricacies of the plant from A to Z, starting from oil gasification to ammonia plant. I know the entire plant. I know what is CO, what is CO2, what is ammonia, and what are the intricacies of ammonia, what will happen. Suppose if it hits ammonia, it hits mankind. So everything should be there. Suppose you want to go to ammonia terminal, you will have board about the ammonia, positive character and negative character. Everything will be there. That should be put. Suppose you want to enter the panel, you should have the positive characters and negative characters of the gas, ammonia gas, whichever may be, whether it is sulfuric acid or phosphoric acid or fertilizer plant. When you enter the panel, all things should be there, should be noted and should have been displayed to prevent any potential of adverse effect. Suppose you are starting a pump, ammonia pump. You must take care of how to start. You have to open the suction valve, close the drain, then start the pump, then slowly develop the discharge pressure. That will not affect anything. Suppose you do it very fast. What has happened? I was given a project when I was with Rom Safety Consultant. The two people, they wanted to transfer from sphere to atmospheric storage tank in 2011. What they happened? Three people, young people of 25 years, they have started. So you have to open very slowly the downstream wall, upstream wall of the tank, very slowly. You have to, so that when you have equal pressure, open it fully. What they have done, they have opened very fully. In the bargain, they lost their lives. So you must have to prevent any potential of adverse effect. Increase organization, reputation, success of business. Suppose you work hard with positive thinking, positive mind, positive character, and to every supervisor, they should go to the concerned section. They should talk with the employees about the day-to-day happenings. If they do it, the problem of negative thinking will not be there. Positive thinking will be applied. That increase the organization, reputation, and success of business. That if you do that, automatically it will fulfill the legal requirement. Zero injuries to the people, contractors, and visitors. Zero tolerance. You cannot have negativity. Negative thinking will not. Behavior-based safety, the most important thing. Dr. Cruz has said, if you have negative thinking, that will doom your career. Negative thing will be avoided. Negative thinking, negative character, negative mind. You should have positive mind, positive character, and positive thinking. You can do wonders in any part of the world, in any part of the world, in any eventuality. Zero compromise. There is no zero compromise. We were the first people, Coromandel International people, we were the first people to introduce safety, process safety management system in 1995. Zero impacts. For that, if you have that thinking, positive mind and character and thinking, you have, that will impact your families and communities. So I am coming to webinar on process safety management system. First, so during US labor of administration, first they had only 14 elements. Now they have given 17 elements. That is process safety information, process hazard analysis, operating procedure, training, contractors training, pre-startup safety review, mechanical integrity, hot work permit, management of change, incident investigation, emergency response and planning, compliance audit, trade secrets, and employee involvement. So the problems start. Develop an safety information, identifying the workplace, chemical process hazard, equipment used in the process, and technology as well. Perform your workplace hazard as a statement that including identification of potential reasons of accidental release that had a potential. Develop on written safety information, the workplace. Suppose I have worked in ammonia ammonia terminal for about 10 years. I was the chief man till my retirement. So I should know what to do and what not to do. But during my days, people never cared for safety. My technician, they never cared. So I will go at morning 6 o'clock. Suppose they want to take the compressor, some compressor got, some centrifugal compressor gone at early morning. So I went and depressurized the unit. By 9 o'clock, I gave the class 2 permit. After draining all the oil and the ammonia, I gave to the mechanical foreman. That was the system I was doing. Even today, because for this webinar, I was preparing from the morning itself, how to do things. That is the positive mind of character and positive thinking and positive way of doing it. If you do that, if you know the hazard equipment used in the process, if you know that, it is well and good, you can avoid accident. So you must know what is ammonia, what is to be done, what not to be done. You must understand the basics of ammonia, because you cannot go to the plant just like that. You must go and train the people what kind of training you have to give, toolbox talking, and every 3 months training of the process operators. You have to, if you do that, the management, if the management advises you to take classes on ammonia, then you can be happy. You can be very well be happy. So perform your workplace audit as a statement, including identification of potential reasons of accident results and that had a potential. You can tell the people what are the possibilities of hazard release. Suppose you want to encounter ammonia when you are doing work, how to depressurize system, how to do things, how to start the pump, ammonia pump, vertical pump, how to start. So these are the basic criteria in the plant, how to start things. So you have to identify what is happening. You have to explore the possibility of what you have to do. So you have to set goals, how the people are knowing the plant well. Then the alternative. If they don't know, you have to put them alternative things. How to learn the plant. Select people. Select some 4 or 5 people under your guidance. Ask them to do it. Implement the suggestion given by you, even though you are well-known figure in ammonia plant. That doesn't mean you have to hear somebody is giving you advice. That you have to implement. That has to be evaluated every now and then. So this is the problem. Now the standard works. Establish system with respect to the workplace hazard assessment findings. We shall address prevention, mitigation, emergency response. So if there is ammonia leak, what you have to do? You must, then the hazard is coming. Before establishing the plant, what we have done? We have done hazard study. After establishing ammonia terminal, it came in 1995 because we have scrapped the ammonia plant, and as well as the spear system was shelved because we wanted to have it bigger ammonia terminal, ammonia tank for about atmospheric storage tank 12,500 tons. We wanted to build. So we have done hazard study before commissioning and after commissioning. If you do that, you can avoid accident. So you have to do emergency response and planning. Disaster management is there. There are so many things which you can do it. Review the hazard assessment and response system. What is hazard? If ammonia is a pungent smell odor, if more than 30 ppm, it cannot kill him. Suppose you want to go near ammonia compressor, you cannot have it. The sound, if you can, more than 30 decibels you can hear. Beyond that, you have to wear earplug. So these are the basic hazard assessment and response system. To understand PSM and its requirement employees and employers are hard to understand how the OSHA uses the same process to mean any actuary involving a highly hazardous chemical. So you must know, you must understand what is process safety management system, how to utilize things. There are 14 elements in which you have to undertake what are the basic character. You have to do a lot of things. Process safety management is not just like that. It has been prepared with so much energy. They have developed the process safety management under US Administration of Labor. So you have to be very careful, whatever, whether the chemical process industry or mechanical industry, it applies. The PSM is applies to all the industry. Process safety information. Employers complete a compilation of written process safety information before conducting any process by the standard. Information on the hazards of the highly hazard chemical. Information about the technology of the process. Information on the equipment. So when we wanted to start ammonia atmospheric storage tank, nobody knows what is what. One German engineer came from all the way. He was a chemical engineer, mechanical engineer, instrument engineer, and electrical engineer. I was going along with him for about 6 months and done a lot of things. I come to understand what is what. I was able to know what is what are the intricacies of the plant. Then there I was in ammonia plant, ammonia terminal for about 10 years, from 1997 to 2008. If any problem comes, I will go and sit down with the people who are coming from far off places, from Pune and so many places. If they want to take up the centrifugal compressor performance, I will sit down. I never take care for my food or anything. I'll try to learn things. That is the way of working. So the employees complete a compilation of written process safety information. Process safety information, if there is ammonia, if there is sulfuric acid, you must have compiled what are the basic things you should know about safety. Safety is more important. If there is shutdown, we don't care. If safety is enforced, you can enjoy the running of the plant. Before conducting any process by the standard, then it is a must. Information on the hazard of the highly industrial chemical, hazardous chemical will be notified on the panel itself. Suppose ammonia or sulfuric acid or phosphoric acid. Before they enter the panel, that will be noted. That will be displayed in the board itself. Information about the technology of the process you can get from SOP, Standard Operating Procedure. Information on the equipment you will get to know from the SOP. So I am giving a small example. When 2019, I went and done safety audit near cement plant, Chettinad Cement Factory at Alattur. People are very well educated. They don't know the SOP. Nobody knows about SOP. I started crying and gave them right and left. Bluntly, I told them, how you are mechanical people, chemical engineering people, when you don't have SOP on the panel, how can you run the plant? They said, no, sir, we are having so much experience. Oh, that is not the way. When you get into the plant, you must know SOP, Standard Operating Procedures, and then so many things about the plant. That we had in our plant in Coromandel International. When you visit the panel, everything will be there. I used to study in night shift, the entire portion of the process and so many things. That is the way of cultivated my habit. Process safety information, process chemicals, ingredients, process technology, how it is manufacturing, process equipment, whether it is a compressor or any vessel for the matter. Everything we should have standard operating procedure. Then process hazard analysis. The process analysis, a thoroughly ordered systematic approach for identifying highly hazardous chemicals. So you must have process hazard analysis. You have to do hazard. The employer must following the method hazard and operability studies, failure mode effect analysis, fault analysis. What is hazard? Hazard has to be done before commissioning or after commissioning. Suppose they want to take up, it will be consist of process engineer, instrument engineer, and general manager of the factory, and the operators and mechanical people. And all will sit together. They will conduct hazard study on process hazard analysis. It is called hazard and operability study. So I don't want to go into the details because it is a big subject. So you have to use, then they will discuss about how the process is going on. Suppose there is a leak on the upstream side of the controller. What will be? So that they synonym, they will no MLA pro, no flow, more flow, as well as pot of rigor and against. No MLA pro, using volume, temperature, pressure, and flow and level. So these are the basic ingredients with that they will try to analyze hazard study. No MLA pro, no flow, more flow, as well as pot of reverse and as well as and against. So these are the synonyms with pressure, volume, flow, and level. They will try to formulate hazard study. Before commissioning, after commissioning, if there is leak, what will happen? If there is after the controller, what will happen? They will try to analyze lot of things. So these are the basic ingredients of hazard. So I don't want to go into the details. Last year I have done a small example I am giving you. Last year I went to Hyderabad, do hazard study on chain pulley links. There are 9 small furnaces and 3 big furnaces. They were using small furnaces. They are using methanol, ammonia, and LPG. For big furnaces, they were using ammonia and methanol. There I told them everything about hazard operability study. I told them this is not. I have done that hazard. I was given a lakh of rupees for doing that hazard study. So they gave me a good check for that. I have done for 3 months. I have done it. Failure mode effect analysis. What is failure mode effect analysis? Failure mode effect analysis, it depends upon design, process, and product. Failure mode effect analysis. So you have to design a product, design the material, you have designed the. I'm giving you a small example. I don't want to go into the details because it is a big subject. Failure mode effect analysis is something big ocean. So if I want to take up, that will take time. Suppose you are a car coming out of the automobile section for painting. Suppose the door gets damaged. What will you do? That is over. The design is static. So you have to be very careful. Suppose you are in a velodrome, the cycle is race bike is being contested for any failures. Suppose you apply the left brake, it has to stop. If it does not stop, you have to apply the right side brakes. Then you have to find out the system, why it has failed. That is called FMEA, criticality analysis. There you get induced reasoning and defective reasoning. So the conclusion from top to bottom, from conclusion from bottom to top, then you have to derive it. So this is FMEA. Faulty analysis. Faulty analysis, suppose an incident happens. That doesn't mean accident should happen. It was found out by the Bell Laboratories in 1962 using Boolean algebra and algorithm using complex numbers 1 to 0, 1 to 3 and normal numbers 0 to 10. Suppose the aeroplane goes, a small example, suppose the aeroplane goes in the air, suppose the valve fails. Air fuel valve fails. It has to come down to the nearest airport and they get things done. It is a small example. What has happened in 13th Apollo aircraft, when they got dismantled, when they came to the earth, they used only faulty analysis they have used and used by reliability engineers of the United States. Okay, so I have given small examples. I don't have time to have to run through. Already 10:40. Operating procedures. The employer must develop important return operating procedures. Initial startup, operating operation, temporary operation, emergency operation. Initial startup, what you have to do? Suppose the plant shut down, the ammonia stream gets shut down for 20 days. What we have been doing, we will shut down the plant accordingly for 20 days. Then slowly we start air separation unit. Then we get oxygen, nitrogen from the distillation column, simple distillation column. Oxygen from the upper of the minus, nitrogen from upper column, oxygen from lower column. So we get nitrogen and oxygen that will be compressed, sent to the oil gasification line. Slowly we'll start downstream units. So you must have 20 days program, how we have to isolate the entire plant, and slowly you have to start the plant accordingly. Operation. What are the normal operation you have to do when the level, flow, pressure, temperature? What you have to do when you start the equipment? Suppose you want to start the pump, you have to open the suction, open the priming cock. When the liquid flows normally, close the drain cock valve and start the pump, then slowly open the discharge valve. These are the normal procedure you do. Operation. And then about instrument, when I joined working in 1971, I was using only annual instrument using air pressure. Now we have got the air pressure is converted to the electrical energy. It has become digital. Temporary operation. When there is a power failure, what will you do? When there is a leak, what will be the sequence? How you have to operate? How to shut down the plant, and you have to restart the plant. Emergency operation. When there is a power failure, when there is a heavy leak, untoward thing happened, you have to know, you should have all the proper procedure you have to adopt. They should be placed in SOP. Employees' participation. Employees' participation helps to control the process related work. Employees must develop a written plan of action to implement the employee's vision. Participation required by PSM. They should provide employees and their representatives access to the process-based analysis and knowledge. So everything you must know, employees' participation, that is the toolbox talk. Suppose an operator does a mistake, it should not be taken to task immediately. You should have humility, humanity, communication, compassion, humility, and humanity. That shapes PSM. What is communication? Communication between the employees and the supervisors and the managers should be cordial. Suppose the supervisor wanted to tell the people, he has to go to the level of the operator and tell about what are the plant material, what are the things you are taking care of. You have to tell them. That is called communication between the management. The manager has to take care of supervisors and operators, and they have to tell the management. That is called communication. Then compassion. Suppose an operator does a mistake. What will you do? You must not take him to task. You must give proper guidance for 3 or 4 times how he thinks, how he doing things again. If he does the same mistake, you can put him to task. So that is called compassion, compassionate ground. Then humility. Humility, as supervisor or manager, they should not have, I know everything. You should go to the level of the people and tell them what to do and what not to do. If you do that, that will bring positive character in mind. Then humanity. Humanity at sea. There is a proverb called humanity at sea. When there is a problem, you should go to the people and tell them how to do things. You must go and work. I have been doing. I never cared for anything. I work like an operator. I came from the operator level to senior executive level. I never cared for anything. I go to the level and tell them how to do things better. You must work with your bare hand. So that is the knowledge. OSHA believes training. OSHA believes that the implementation of an effective training program is one of the important steps to take, hence presently involved in operations. People should know about the process and its procedures, that employees have the required to operate the plant and operating procedures. OSHA believes the implementation of proper training. The people have to undergo training every 6 months. When they don't know, you have to put them under training effectively and see that they do it in better way. If they don't know the process of operation, you must go and tell them, take them to task, ask them to go for training every 6 months and tell them, every day you tell them blatantly, no question of hesitation. Tell them, then they will come to realize, so their work is more important than other things. So the people should be aware of process and procedures. That requires wisdom and to operate the plant and the operating procedures. Refresher training. Refresher training has to be given for every employee, at least every 3 years. Yes, that is the most wonderful thing. For every employee, they have to undergo the nonsense of the game. Nonsense of the game. Suppose a football player plays, he doesn't know anything about basic. He has to undergo training for 6 months. The same way, every operator or every employee has to undergo training regarding their plant or anything, whether it is a mechanical or electrical, chemical or anything. They should undergo the basic. I am very strong in basic. That's why I've joined as a process safety consultant. Record training document. Training documentation. Record of the employee must be containing their identity. Of the employee, the date of training, how the employee is verified that the employee understood the training. So record code of the employee must be containing the identity of the employee, the date of training, how the employee is verified. Then the employee understood that. So you must have the record code of the employee containing their identity, of the employee, the date of training, how the employee was as verified. Then the employee understood the training, documentation and training. Based, focused on what information, focused on when and why, communicates the facts, provide situational context for tasks, organization into small task-based chunks, may contain chunks of documentation, provide user-directed navigation, measures learning with assessment, used as needed, used for a limited time. These are the, you must know documentation, you must know training. These are the basic things that will give you. Documentation and training are complementary tools that work together. It is possible that the right solution might be as a combination of the documentation and training address the goals and challenger of this situation. Contractors control. Employees may be present at a particular site and that they should know all the procedures and process of the particular plant. I have seen in a fertilizer plant where I was working, monoammonium plant, the workers, contract workers know very well about the plant than the paid permanent workers. That was the situation. So slowly, all employees were weeded out and contract employees were employed as paid workers. So that was the situation when I was working in monoammonium phosphate plant. They should undergo PSM only in the case of emergency crisis. They can be utilized. Suppose they get acquainted with process safety management, they can be utilized well. Contractor employer should evaluate regarding contract employees' performance. So when you choose a contractor employer, you should choose a correct person. He knows capabilities of running the plant well. The one example, one Mr. I don't know, I have forgotten his name. He knows about all the fertilizer plant very well. He used to run the plant without anybody. One worker was there, one Mr. Thomas. He used to run the plant well than operators. He knows the intricacies of the plant well. He retired as an operator. He joined as a casual and retired as an operator W, work staff grade 2. So that was the situation. He's from Kerala. Focus on key roles and responsibilities. About site senior executives, training standard for the process safety leadership, site leadership, training standard for process safety management, technical specialties, gold standard for process safety specialists, frontline supervisors, training standard to be developed, frontline staff, training standard to be developed. These are the basic things for employees' responsibilities when they employ contractors.
Excuse me, Narasimhan sir. Thank you very much.
Okay.
Sorry for disturbing.
Thank you. Thank you.
Yeah,
you have given me enough time. I could not.
You couldn't finish. I know that there are still halfway to go. Actually, we have given you the shortest time That is the reason why we couldn't able to accommodate, because we are having another speaker also, and
Okay.
definitely we'll arrange a separate session for you. And
Okay.
thank you for being with us. And
Okay. Thank you. Thank you.
thank you, sir.
So I
Thank you.
can finish it now. I can go to my curriculum, sleep.
Thank you, sir. Thank you very much.
Thank you. Thank you.
Okay.
Thank you.
Thank you.
How is the subject? What I talked?
It was excellent, sir. There is no doubt about it. And you are extremely, knowledgeable, and there is no words to say. You are,
Okay.
yeah. Okay.
Thank you. Thank you.
So
Okay,
everyone
Venkatramana.
got good information from
We
you.
can have separate section. No, we can have separate.
Definitely, sir. We'll come back to you, and
Okay.
we'll have a separate session as discussed. Thank you very much.
Okay. It will take 2.5 hours complete to give you example. ASSP study, I have to give a lot of example. I have not given. Just like that, I have gone through.
Yes,
Okay.
sir.
Carry on. Carry on.
Thank you.
Okay.
Thank you very much.
Good night. Good night.
Good night, sir. Now I request our secretary to. I'm sorry. Now I request Mr. Mr. Najas to introduce the next speaker.
Thank you, Narasimha sir. It was wonderful speech. Anyway, we couldn't able to complete, so we'll try to arrange one more section to have complete. So let me welcome the next speaker, Mr. Tata Venkata Suryaprakash. He's my colleague and he's a design engineer and very much familiar with the process safety. And he's also worked in front-end engineering design, which is the initial design part of any process plan. And he had a lot of us to discuss regarding the lead AP. Okay, so let me welcome Mr. Tata Venkat Prakash to for his wonderful speech. Mr. Tata Venkat, are you there?
Yeah, am I audible?
Yes, thank you. Go ahead.
Yeah. Thank you, Najas. Good evening, everybody. As he introduced me, we both working together with Woli now. And it's been, I am in association with the ASSP for quite a long time, and most of you might be aware of me. And thank you, Narsimhanji, for your wonderful session. Our interactions offline reflects in your presentation. Today, I have chosen a topic, AP Leap. Basically, before getting details of this subject, which I have chosen it as part of my professional development practice, which I am going for some chartered membership of an institute, for which I am doing a detailed elaboration on this subject. And I got this opportunity to present it to you guys to get your feedback on how it works for the forthcoming improvement of the process safety system globally. So now there are around 30% of the global major accident hazards that have happened, whether it is Flixbug UK in 74 or Conqueror Phillips accident in 2001 or the Chevron US incident in 2012. They all having one common factor, that is aging, is still a disturbing phenomenon because chemical process industries have been facing this issue for quite some time because of these aging plants, which were basically leading to these more major accident hazards globally. So I have chosen a topic called aging plant life evaluation and extension process, which is a beneficiary if you make the right decision about your aging assets at a right time. It will maximize your value and it is reduce your risks, and it will improve its availability beyond its life cycle. And also it will automatically, when you increase it, it will increase your returns. So that is very important thing. So overall, the what is an aging plant? Basically, aging plant is a plant basically which is maybe no longer considered fully fit for the purpose due to deterioration or obsolescence in its integrity or functional performance. Aging, not necessarily it is the age. For example, when we are designing a plant, basically, for example, we will design it for a lifetime of say 25 years. So, but some plants, before reaching that their chronological age, they get into so many accidents. We will see so many near misses and process safety, loss of containment incidents. Some have some major accidents like fire and explosion, etc. happens in those plants. That means it is deteriorating before that it is supposed to be did. So there are certain international standards which give some guidelines on it, like COMA or the HSE executive has developed some interesting standards to do achieving this one. So I will take you through the macro assessment of the aging plant life assessment. For example, when you are doing a macro assessment, so you need to identify what are the urgent action assets. Your asset where it stands. Basically, you need to do an assessment for it. So first you need to identify the bad actors. For example, safety critical elements and the criticality of the assets that are there. You need to identify that. Based on those safety critical event failures, you will assess that yes, this kind of my asset is aging quickly than expected, and I need to take an urgent action to rectify or to avoid major accident. Then the next level is replaced assets. For example, when you are having a asset which is supposed to go for a 5 years plan, for example, every 5 years you are going to go for a turnaround to maintain it. But in between that, so many loss of containment incidents or near misses or accidents happening means your deteriorate levels are increasing. So that need to be assessed. And the third phase is new balance life of the asset need to be assessed. And that for that also this assessment will help you. What is the remnant life of your asset? For example, if you see the globally if you see the world at large, for example, in UAE itself, there are around 12,000 assets are there for the gas stove. And for example, in Singapore, Power is having around 2,000 assets. And in Atlantic, if you have close to 15,000 assets, they are having. And in the Armor Energy, Australia, and etc., gas and oil plants, close to 2,000 assets are there. In Kuwait, we have many hundreds of assets under KOC, Kuwait refinery, etc. They are functioning. These all have one common factor in which is affecting them is their lifetime. For example, some are deteriorating earlier than the expected. Some are deteriorating later. Some are deteriorating, before the lifetime is completed. Like for example, I say an asset is designed for a 25 years lifetime, but your asset is got damaged quicker than that means there is something that going wrong. Either it is the design mistake, or it is the design specifications were wrong, or the useful service life design life is not good, or the running parameters were not properly designed for it, or the historical data like breakdown history, inspection and repair and replacements is not done effectively periodically, and performance and condition monitoring reports were not done, and current and condition assessment is not carried out. So what are the basic way and approach for this one? How we can do it? For example, I will tell you for example, in human assessment, for example, if you see in behavior based and safety, when we are talking about it, we will talk about critical behavior inventory. That is for the humans, how they are working, how they are performing their jobs, etc. We will do an observation at sites. For example, behavior basis safety, you do there. Somebody is in the line of fire, somebody in the pinch point, somebody is doing work badly, or his organized position is wrong, etc. That is for human behavioral assessment we will do it. So for the equipment or asset, what we will do it? So by human equipment performance behavior in inventory, that is FMEI is your basic guide for it. For example, as Narsahanji earlier told about talking about the studies that we do, he talked lightly about FMEA. Failure mode effect analysis is a very, very interesting tool for ensuring that your reliability of the equipment that you have designed have functioning effectively. Because every equipment has an failure data with it. It comes through global standard practices like ORIDA and etc. Even equipment manufacturers themselves, they will provide their failure data. Based on that, when you are operating a facility, you need to take those data into consideration and periodically assess whether based on within the limits of those failure rates, your system is functioning or not. You need to assess it. that those things need to be established properly. Then the process safety of your equipment or your functions, for example, pumps, vessels, etc., whatever their manufactured data based on that is functioning or not, you can make sure that it is functioning effectively. Now when you go to assessment life of AP leap, aging plant life evaluation and assessment process, when you go in deep into it, for example, you are assessed when you are assessing your asset, you need to understand certain things. For example, asset health index you need to develop. How you will develop an asset health index? This based on your corrosion risk management, risk assessment, how corrosion rate is happening, and how the process is functioning, etc. You will develop an asset health index. A value point of life cycle, it gives you a probability of failure degradation curve for any asset. So this is called an asset health index. The health index recognizes that there is a relationship between asset condition and asset life. Because the health in the health index, when you identify in this process, what it will give you is it will give you a relationship between the asset condition as well as the remaining asset life. For example, you designed it as asset for the 25 years, but due to the corrosiveness of the process liquids or things there, it started deteriorating quickly, and you have seen that many places the pipelines leaking and loss of containment happening, and corrosion levels are very high. Then sometimes lot of you need to change before its life. So that is called the health index is directly proportional to the remnant life of your asset. So that is very important thing to be assessed when you are doing the remnant life assessment methodology. For example, some questions we should ask: what is the risk based inspections? I know risk based inspections when they were conducted, and critical behavior of the machines, how you are assessing it. Historical data score, how it is been maintained based on the failure roads and maintenance and repairs. And current condition score you need to establish, which is called CCS, current condition code, and HDS, historical data score, and data assessment or design functionality, and AM score. These things you need to give. For example, discipline based influence factor, when you are assessing it, it is very important to note that based on the functionality and the way it is been maintained, it deteriorates. For example, you are not properly maintaining a pump periodically, so the failure rate of the pump from its design is very higher. So for example, typical useful service life USL, when we are measuring useful service life values for various assets, are based on the data. For example, when you purchase a gas turbine, for example, so they will give you its life. For example, your asset may be designed only for 25 years based on your piping and other things, but certain equipment have more life than that was you are designed for. For example, a gas turbine can survive for 40 years, whereas your power plant may be designed by its piping and other things designed only for 25 years. That means if the gas turbine is fit for you, so your rest of the plant may be aging. So you need to have a proper plan to ensure that you can run the plant for the true life of it. For example, compressors will be having some 30 years lifetime will be given for it, useful service years. Like that, the historical data and the manufacturer data will give you those factors. So based on that, you will identify the plant life, and you will establish a life reduction factor which is equivalent to for example, you will give a standard practice, for example, a 117.5 into a remaining life, like that, and you will calculate the life reduction factor for this one. So when we are getting into life extension of your plant, for example, there is a you constructed a GC, for example, if you take it and it is designed for 25 years, shall we close it after 25 years? Nobody will agree for it because it's still functioning, it is working properly. But then what you will do, you have to conduct a remnant life assessment study. Then based on that, what are the systems that need to be changed and how much life you can extend it, that proper assessment need to be conducted. That assessment maybe you can have different domains for your life extension. For example, you wanted to run the plant for 0 to 5 years, or maybe 6 to 10 years, or 11 to 15 years, or 16 to 20 years. Like these margins you can take a 5 years interval, and when you are giving it to some external agency to assess its life, then they will assess it. Okay, this pump is designed, this turbine is designed for 40 years, whereas it is only 25 years life is completed. So this turbine can function for another 15 years. Then based on this historical oriented data, how many more years it can function, whether it is having a lifetime of 40, but can it sustain for the remaining 15 years. So based on that, the rest of the piping and connecting designs, etc., to be planned accordingly. So you will take the asset selection and scoring template, you will use it. First, you will take the asset existing condition, identification and classification of data. Then you will collect the initial data from your plant. So like the data sheets and as-built drawings and all you will take. Then based on that, you will take the complete history, how the asset is functioned. Then you will do a macro level assessment like bad actor identification and safety critical element assets identification. I am not talking about the studies which we do carry out based during the feed or engineering stage prior to commissioning. This is once a plant is running, in order to have its life extended beyond its designed life, we need to have a proper life assessment, aging plant life assessment, evaluation and assessment extension process. For that, we are talking about this one. So for example, life extension options for you will take runtime will be, for example, continue to run for operate and maintain the equipment in accordance with the company policies and standards. You will run it. So that is one option for you. Continue to monitor the required performance standards so as to ensure that the extent and rate of the future of the life plant, how much is there, and you can, with a small repairs, you can run it for how many years. For example, refurbish. For example, repair is not possible, then refurbish the existing equipment and systems, training and bringing back it to the original performance conditions. Or you can redesign it. For example, you have a design now, maybe after 25 years, the same process, maybe there is an easier process developed, which will be beneficial to you. So then you will redesign it accordingly. You will modify your plan to cater the then compliance requirements there, so that you can redesign it and rerun it. Then you can reassess it and you can re-rate it. That will help you to analyze the margin between the equipment functionality ability and that required to provide the required function. For example, if you have a big pump, injection pump you are having, for example, if you take, okay, it is designed for a life of 25 years and it has to run continuously during its lifetime. So after 25 years, even though the life is there for another 40 years, certain things may be mandatory to be changed as per vendor recommendations. Those things you need to identify and re-rate them and replace them so that it will give you your asset life for running it for more than the completed lifetime. So this AP leap will help you in assessing those things in accordance with this life extension, so that you can extend your plant life beyond its design life, as well as you can run it safely without any major accident hazards. As we discussed in the beginning of this, when there are major accidents happened right from the 1972 to 2012, even major companies which didn't pay attention to the aging of the plant has faced these problems. For example, you have to identify, for example, additional inspection and increase the frequency. For example, corrosion monitoring and inspection and corrosion requirements are nowadays stringent and NACE design is happened. But due to the extended, during design of the plant, you will take a corrosion, rate at certain level. But when plant is running, due to any reasons, maybe because of the compromising with the injection of the corrosion chemicals, or due to our production data, etc., the corrosion rate increases and it leads to deterioration of your piping system. And over a period of time, then the design life, it got damaged, and it leads to loss of containment. Sometimes it may give to major accidents hazards. So we need to be very cautious on those. Those all things need to be recorded, and they have to be accordingly. The plant life need to be adjusted, and accordingly your integrity assurance plans shall be developed. Periodical maintenance plans, predictive and preventive maintenance to be carried out, and replacement of the package or asset or component. For example, it is deteriorated, giving you trouble. Don't compromise for the money. You need to replace the package or asset or the component. And periodically, wherever a vendor given support equipments are provided to you, you need to take the care of the equipment by taking his inputs and taking the vendor on board periodically as an asset developer, so that his recommendations to be implemented always. And operational duty, as initially been discussed about the importance of training, it is very important that we have our operators been trained on the systems according to the requirement, so that they will run the systems effectively. So this way we can, aging plant life extension and evaluation study will help you, so that this will help you to ensure that you are running your plant effectively, and it is helping you to achieve your objectives. Corrosion is one of the mechanisms that is important to be considered in the aging plant life evaluation and assessment. And there is a stress erosion, cracking will happen, there is erosion, and some key important things. Corrosion plays very key role in this. For example, corrosion under insulation is one of the thing, and machines and rotating equipment life, because of the non-maintenance, periodical preventive maintenance, they will lead to some accidents most of the time. Fire heating equipment need to be maintained properly, and their life to be assessed frequently based on the requirement. And concrete support structures, sometimes because of the the topological condition and seismic zoning elasticity. For example, repeated earthquakes are coming, means your concrete support structures may lead to fade down, and that will lead to the increased vibration of the pump during the operation, which generally sometimes it's overlooked, and that is leading to your plant aging event. Also the buried pipes, etc. So the very important of managing the aging plant is very key for us, because we need to understand what is happening with your plant. It is like our age. As we age, certain parts of our body starts functioning differently, and we assess, then we will give medicine to them to make sure that they function effectively. In the same way, your plant also requires medicine in order to ensure that when it is getting aged, it need to be having that medicine to function effectively. So same as as we are aging, we will take some, doctor will suggest us take multivitamins, or you are deficient in vitamin D, means take vitamin D, like that thing. Similarly, as the body is like a machine, it is like a factory. It generates a lot of enzymes, and it is a combination of many plants, frankly we can speak. So like the same way, the plant where you are working and which is giving you food need to be maintained effectively, and it is a collective work of all disciplines, not just the safety people need to raise their flag when they find something, and rest of the people compromise, means say it will not work effectively. When a near miss happens, it has to be recorded, investigated, and effectively its mitigation to be established, and those need to be addressed and tracked to effective closeness, and then it has to be monitored for a period of time, so that it is not recurring. So that is very important aspect of this one. And an aging plant life evaluation and extension procedure developed and established, that will give you your asset life, as well as your productivity also will increase. Thank you very much, ASSP, for this great opportunity. I hope I have done my presentation in within the time. So because I know the time constraints, and it's already 8:45 now. But it's a very elaborative subject. I could not. I don't want to make you spend more on these looking at slides, because sometimes you don't understand the slides. It's better to listen than slides. That's why I prefer to talk only, rather than sharing the slides and the PowerPoint. So because that will not give you idea, because some technical words difficult to understand. So I try to make it easy, so that you can understand wherever you are involved in the process safety management of a function. Aging of the plant is a very key consideration to be given. So with that, I conclude my presentation for today.
Thank you, sir. Thank you very much.
Thank you, Mr. Tata, Venkata, Surya Prakash, and Narasimhan sir. So we'll open for question and answer for 2-3 minutes. Accordingly, we'll move forward. If at all you have any questions, raise your hand. Accordingly, you will be provided an opportunity to ask your question.
Or you can put it in the chat box.
Yeah, better.
Yeah. In the meantime, I'll post the feedback also. Those who participate in the feedback only are going to get the participation certificate. Kindly note and click on the link. Oh, sorry, everyone. Yeah, I'm just hope you have received a link in the chat box. Just click on the link and give your feedback as well. In the meantime.
Simultaneously, you can go for a group photo also, Mr. Venkat.
Yeah, that's correct. Okay, thank you very much. I request everyone to open your cameras to take some beautiful pictures of yours. Kindly open your cameras, whoever can.
It is saying you can't start your video because the host has stopped it.
Really? Okay. Sorry for that. This is security issue because there are some cameras while the presentation going on. Some people were.
Yeah. Good evening, Surya Prakash. This is Krishnan. Excellent. It's an excellent topic. Really, it's a new topic. Many of us. Is there any, in my question, is there any standard or any guidelines available to follow? At least the like KPIs we can put, like a checklist. We can say KPIs, to check. Then we can move or extend the planned life here. Any guidelines kind of things?
There are many standards are there, guidelines from HSC executive are there, and control of major accident, comma gives some guidelines on it. There is actually ORIDA data available globally. Based on that, the equipment life can be assessed. Some organizations, they are doing it in an aging plant life extension study. They have developed their internal softwares like Gasco, etc. They are using their own thing because basically the life extension it is like a new plant building. Once the lifetime is reached or life deterioration is more than expected, then they will go for it. So it is a very vast engineering practice. It is not just like you conduct a PHS study and give a report. It is not like that, because it is like a 6 months assessment study, then during which they variably analyze the engineering data, age built as well as this one. Then based on that, it will give the options. As I told you, you can choose the options are there for 0 to 5 years, one level, then 5 to 10 years second level, and 10 to 15 years, and 15 to 20 years. That is doubling the life of the plant. These questions are there. Then the owner can decide which option he can go for it. Then based on that, the equipment redesign process will go. Then the pre-HS and all, it will be carried out accordingly to it. So this is a very elaborative process.
Yeah. Okay. Thank you.
Thank you. Thank you, Prakashji. I request everyone to open your cameras for a minute or few seconds at least to capture some snaps.
Sorry for the disturbance. Myself don't get camera, sir.
No problem. Whoever is having, please open, because it will be good for our magazines and all. And not only for that, we'll be having like what you can say, the evidence. If someone is saying we attended, we will have this as an evidence to provide the certificates in case they are not going to get it. Usually they will be getting within 24 hours. Whoever is participating in the feedback, they will be receiving the participation certificate within 24 hours.
Take a screenshot, please.
Yeah, it's already done. Thank you very much. Okay, anyway.
2 pages are there. 1, 2, you can guess.
No, it's one only.
Okay.
It's one only. Thank you anyway.
Seems to be Ashok sir is in a flight.
Yeah, Ashok sir, good evening. Thank you. Okay. Anyone would like to talk? You can talk. It will be okay.
Any more questions?
Networking session, you can say. Yeah. Whoever joined first time, no, I request you to unmute yourself and talk. Introduce yourself and let us know how you got able to know about this event. Those who are joining first time, like Mr. Shohel, is it your first time?
No, sir. Actually, I joined the ASSP in 2019, but currently, since last 2023, I came back here in Kuwait, and then I have joined here. But still, I didn't register here in ASSP again. Actually, I have to membership again.
Yeah. Thank you. Anyway for joining. And
Okay, thank you.
I request Dr. Ali Al Hamoud. How was the event?
Actually, this event is very informative, and so many things are new for us. So it is very informative and collectible.
Welcome, Mr. Suhail.
Okay, thank you, sir.
Yeah, I would like to hear about some words from Dr. Ali Al Hamoud.
Yes, thank you very much. Actually, very interesting presentations from both instructors. I learned a lot about process safety management, the 17 elements in the first lecture with real life examples from different industries such as ammonia industry, and also he gave a lot of information about the Bhopal MIC root cause analysis of that catastrophic event, which is until now, as far as I know, there is investigation and there is court orders still between the two countries. And with the second presentation, also it was very interesting that the instructor was very familiar with the subject, that he did not use any PowerPoint presentations. And this is very excellent information. I learned a lot also from it. Thank you very much, both.
Thank you, Dr. Ali Al Hamoud. You are very active and you are always actively participating in the trainings and awareness sessions. And I really appreciate your efforts. Thank you, Doctor.
Yeah, guys, good evening. This is Hizar Hayat.
Good evening.
Hopefully, you all are going to do well.
Hizar?
Yeah, Hizar Hayat. So,
yeah, okay.
I'm kind of an active member of your all the sessions. So I'm very happy, very delighted that I have another session on it. I was busy in middle, but it was quite understandable and nice about the process safety management. So I really appreciate that one, and I really appreciate ASSP and all of their efforts toward health and
Thank you, Mr. Kizar. We lost you actually. Anyway, means disconnection, some audio disconnection happened. Anyway, thank you for your feedback. Any others? Okay, thank you. Because we are delaying, it's already about to go for 9 o'clock. Okay, I request our Vice President, Mr. Muhammad Yusuf, to give his closing remarks.
Yeah, Bismillah ar-Rahman ar-Rahim. Assalamu alaikum. A very good evening to all of you. Am I audible? Am I audible?
Yes, you are audible.
Yeah, okay.
Loud and clear.
First of all, I like to thank our today's speakers, Venkata Square. It's rather, I can say, Venkata Cube, because our first speaker is Mr. Venkatachari Narasimha, and our second speaker is Tata Venkata Surya Prakash, and our senior executive is Venkata Ramanna. So we had today Venkata Cubes. So it was very nice. So the first speaker, Mr. Venkatachari Narasimha, Like he gave the detailed this one his experience, and mashallah, it was very nice. This is the certificate of appreciation, which is a token of appreciation which we like to give from ASSP. So from my bottom of the heart, I like to thank our today's speaker, Mr. Venkata Narsimha, Venkatachari Narsimha, for giving such a detailed and uh, practical experience for the PSM, which he shared everything in detail about the risk, about the hazard, about the objectives, and the 14 elements which was there in PSM. Then how he related this one to the present 17 elements. He talked about SOP, hazard, the PHA methods, fault mode, effect analysis, poultry analysis, and toolbox talk. Everything. Really, it's a great thing that it's a vast subject, but he tried to uh, put it in half an hour. So really, it's a great thing. And mashallah, it was very good experience which we had. The fertilizer company which he was explaining about the urea, the sulfuric acid. Really, these are the very toxic gas. Urea, this one ammonia, and the sulfuric acid. It is one of the king of acids. This one, it is very dangerous, which we say. But mashallah, he just to put everything in half an hour. It's really great thing, and thank you very much. Thanks for giving so much time for us, and mashallah, it was a very excellent presentation. Now I like to go to our second speaker, Mr. Tata Venkata Surya Prakash. Mashallah, really, it was a great thing. Everything he gave in half an hour. Everything. It's really a vast subject, which it is not at all possible to sum up in half an hour. But still, Mr. Venkata Surya Prakash, he tried his level best to put it in simple words, and he gave everything. This one, that 30% of the incidents which are happening because of the aging plant, life evaluation and extension process. So we see when we go and purchase a medicine, it is written there the expiry date. So everything in this world has the expiry date, and every company, every tool, every equipment which we are taking, it has the expiry. So it has to be like he everything scanned everything, and they see like if we are uh, aging, then we go for scanning, and we'll come to know what are the organs, how it is functioning, everything the same way. Like he has summed up everything about the company, what are the equipments, and the aging of the equipments, the life assessment study, everything in detail. Really, it was excellent thing, and mashallah, it was very interesting. And thank you very much for giving the time for us. And I thank our head of the Energy and Sustainability Committee, head Mr. Najaz Abdul Karim, for giving such a good speakers for this PSM technical meet. Thank you for your efforts, and thanks for both the speakers. Thank you very much, and thanks for all of you who attended this training. And mashallah, it was very good thing. And please be with us, and shake your hands with the ASSP to grow yourself in the future. Thank you very much. Thanks. Thank you.
Excuse me. Anybody wants to be part of the webinar as a speaker, please contact with us. Okay, you can chat. You can contact Mr. Ramana or myself. Thank you. And if you have new members, can you please introduce yourself? We'll have some 5 minutes for networking, because this is an opportunity where we can meet different people having different experience in PSM as well as in other areas. So we'd like to have a guide with us where at least where we are working, and some sort of networking. I think it is better. Can we call randomly?
Yeah. We have called a few speakers, few participants, I mean. Now,
Mr. Sulfikar Ali, are you there? Mr. Sulfikar Ali, can I? Okay. Okay, let us wind up. Back to
yeah,
Ramana. Mr.
yeah, thank you, Najaji. And thank you everyone for joining, and we'll meet in the next event. Thank you very much. Good night.
Thank you, everybody. Good night.
Thank you.
Good night.
Thank you all. Thank you all. Good night.
Thank you, Mr. Ramana, especially. Thanks a lot.
Thanks to all. Good night.